Okay, so there's a couple different ways of looking at this. So this is a plot of a vector field, and I just was getting this set up, so I did x plus y squared, and we'll come back to that in a minute. So instead I'm just going to say that the direction you're going at any point y, the slope you have at any point y, or any point, sorry, xy, like the slope at the point 3, 2 is just whatever the y value is.
Okay.
So that's a slope. So at 3, 2, your slope would be?
2.
At 4, 0, your slope would be?
0.
So what does it mean to have a slope of 0?
You're going flat.
Okay, you're going flat across. So I'm going to use this vector plot function to plot this. So what do you think this slope field is going to look like if the slope at every point y has a slope of y?
So it's gradually going to start kind of turning up. Something like that.
So you're going to start at 0, then it's going to be shallow, but getting steeper and steeper and steeper until it's, I think we're actually only going up to 4, so it's not actually going to get all that steep.
Well, a slope of 4 is pretty steep. It means you go up 4 for every 1 you go over. But 0 is here, so this is 0, 0 is right here.
So that means
we
it would
start
go down.
pointing down.
Okay.
Down and up.
Alright, so let me run this. And I'm going to make 2 plots. The first plot is going to be a plot where the arrows are different lengths, so that's sort of direction and speed, like you guys saw before. And then I'm going to have a plot below where it's only direction. I make all the vectors have a length of 1. So first we'll look at this plot. Alright, this is where the slope is equal to y everywhere.
Yep.
So is that what you were expecting to see?
Yeah.
Alright, so as much as I don't like putting things on the screen, I want you to tell me, like, pick a point, like say right here. If I put a balloon right there, can you tell me where would it go?
Well, it would kind of go up gradual and then go kind of up more drastically.
All right.
Just keep going up.
All right. So if you imagined the path of that function, does that remind you of any functions that you've seen before?
Maybe some sort of exponential function where it's like maybe y equals x squared.
Y equals x squared. Okay. What about you? What do you think?
Parabola.
Yeah, I would say either an exponential function or a parabola cubic 4th degree.
All right. So the interesting thing is, looking at these arrows here, do you think this would produce a parabola shape?
I don't actually think. I mean, we do have some sort of curve up.
Okay.
But it's not like the actual shape.
I don't think it's described by a parabola.
Okay. And you said exponential function too. So what exponential function are you thinking of?
Could do like, I don't know, maybe like 2 to the x.
2 to the x maybe? Okay. And we'll go down here. This is where I make the arrows all normalized. So now it's just only telling me the direction, not telling me the speed. And so you see that 0 slope now.
Yeah.
Because before it was at the 0 slope, it also had 0 speed. So it didn't really show up very much. But here you see, and you are correct in your guess that this produces an exponential curve, like e to the x, or like 2 to the x. Okay, but now I'm going to change it to f of xy. The slope is now x. The slope is now determined by the x value rather than the y value.
So
what do you think this is going to look like?
So are we going from what's the okay.
Negative 5 to 5, and y goes from minus 5 to 5.
Okay.
Slope is determined by the x value.
I think this is just going to turn this kind of on its side. So we're going to have the 0 is going to go right to the middle here.
Okay.
And then we're going to have it, I guess, curving down steeply in this row, then less steeply, getting to 0, then curving, or I guess just going, not really curving, but going up shallow, then steeper and steeper and steeper.
Okay. And what's a curve that you think? Here, I'm going to take you to have your brother's description. He said it's going to be very steeply pointing down here, then less steeply, then flat, sort of in the middle, and then going up more steeply. So what kind of curve does that?
well, it's going like down and then kind of back up and then down and kind of back up on both sides.
Yeah. What kind of curve does that?
Maybe like not the curve. Sort of like a parabola, but
Okay. What do you think?
Maybe a cubic would do that.
Maybe a cubic. Oh, okay. So we do have a difference. So here's what this one looks like. So there's the ones with the speed as well, but here it is just only with the direction. So what do you think this shape might be?
Yeah, this
it's
looks
interesting.
a bit different. Oh, this is probably closer to a parabola or a fourth degree, or something with x to the even power.
It does kind of look like there's a sharper curve to it, and it sort of looks like in the middle there's like a space where it just kind of dips down, and this is all flat. There's a path running through there.
All right. So if you put your pen on the screen again, if you put a point there, what would it do?
Just go down and then back up.
Yeah. So this is actually a parabola, which is pretty cool. But now I'm going to let you pick your own functions.
All right.
All right.